In this course, we will explore an important foundation of robotic process automation, or RPA, by understanding the process methodologies that help organizations improve efficiency before they automate their business processes. Automation alone cannot solve inefficient workflows. If a poor process is automated, it simply performs the same mistakes faster. That is why organizations first optimize their processes using proven methodologies before introducing software robots. Throughout this discussion, we will focus on three widely used approaches: Lean, Six Sigma, and Lean Six Sigma. Each methodology addresses a different aspect of process improvement, but together they create a powerful framework for operational excellence. Lean is primarily concerned with improving efficiency. Its main objective is to identify and eliminate activities that do not add value to the customer. These activities may include unnecessary waiting, excessive movement of materials, repeated work, errors, or delays. By removing these forms of waste, organizations can complete their work faster while using fewer resources. Six Sigma takes a different approach. Instead of focusing mainly on speed, it concentrates on quality and consistency. It uses statistical methods and data analysis to identify variations and defects in a process. The goal is to reduce errors so that products and services are delivered consistently with high quality. This makes processes more reliable and predictable. Many modern organizations combine the strengths of both approaches through Lean Six Sigma. This integrated methodology aims to achieve efficient operations while maintaining strict quality standards. In other words, Lean helps organizations do things faster by removing waste, while Six Sigma helps them do things correctly by reducing defects. Together, they maximize customer value by delivering products and services that are both efficient and dependable. As we continue through this module, we will study each of these methodologies in greater detail and understand how they provide the ideal foundation for successful robotic process automation initiatives. Before an organization can successfully implement robotic process automation, it must first understand how its existing business processes operate. This is where process methodologies become essential. They provide structured approaches for analyzing, improving, and preparing business workflows so that automation delivers maximum value, instead of simply accelerating inefficient tasks. The first methodology is Lean. Lean focuses on efficiency by eliminating activities that do not create value for the customer. These unnecessary activities are commonly referred to as waste. Waste can appear in many forms, such as unnecessary waiting time, repeated work, excessive movement, overprocessing, or delays between tasks. By identifying and removing these inefficiencies, organizations can complete their work faster, reduce costs, and make better use of their available resources. The second methodology is Six Sigma, which focuses on quality and consistency. Unlike Lean, which aims to reduce waste, Six Sigma seeks to reduce variation and defects in a process. A variation means that the same process produces different results under similar conditions, while a defect is any outcome that fails to meet the required standard or customer expectation. Six Sigma uses data and statistical analysis to understand why these defects occur, and then improves the process to produce more reliable and consistent results. The final approach combines the strengths of both methodologies, and is known as Lean Six Sigma. Instead of choosing between speed and quality, Lean Six Sigma achieves both simultaneously. Lean removes unnecessary activities to make processes more efficient, while Six Sigma ensures those processes consistently produce high-quality outcomes with minimal errors. Consider a bank processing loan applications. Lean principles can reduce unnecessary approval steps and eliminate delays, allowing applications to move through the system more quickly. At the same time, Six Sigma techniques ensure that customer information is entered accurately and that approval decisions are consistent. Together, these improvements create an optimized process that is both efficient and reliable, making it an excellent candidate for automation using RPA. This understanding of Lean Six Sigma and Lean Six Sigma forms the foundation for all the process improvement techniques we will explore throughout this module. Lean is one of the most influential process improvement methodologies used in industries today. Its primary objective is to maximize efficiency by systematically eliminating anything that does not add value to the final product or service. In simple terms, Lean encourages organizations to accomplish more with fewer resources by reducing waste, minimizing errors, and eliminating unnecessary delays. When we talk about waste in Lean, we are referring to activities that consume time, effort, or money without benefiting the customer. For example, if a customer submits an online application and it remains waiting for approval for several days without any useful work being performed, that waiting time is considered waste. Similarly, repeatedly entering the same data into multiple systems is another form of waste that Lean seeks to eliminate. An important aspect of Lean is that it is not simply a collection of tools or techniques. It represents a cultural transformation within an organization. This means every employee, from top management to operational staff, must adopt a mindset of continuously looking for opportunities to improve processes. Instead of relying on quick fixes for individual problems, organizations develop long-term habits of identifying inefficiencies and making gradual improvements over time. The slide also highlights that Lean does not follow a rigid, one-size-fits-all approach. Every organization has different products, services, customers, and workflows. As a result, companies often customize Lean principles to suit their specific business environment. For example, a hospital may apply Lean to reduce patient waiting times, while a software company may use Lean to streamline its software development process. Although the applications differ, the underlying objective remains the same: deliver greater value by removing unnecessary activities. The accompanying image of a well-organized workspace reinforces this idea. An organized environment supports efficient work by reducing distractions, making resources easy to locate, and allowing employees to focus on value-adding tasks. Whether the work is performed manually or through software automation, a clean and well-structured process always leads to better productivity. Understanding Lean is particularly important for robotic process automation, because software robots should automate optimized processes rather than inefficient ones. The history of Lean manufacturing can be better understood by examining one of the most significant innovations in industrial production. In 1913, Henry Ford introduced the moving assembly line, a breakthrough that completely transformed manufacturing. Instead of workers building an entire product from start to finish, the product moved along an assembly line, while each worker performed a specific task. This specialization dramatically reduced production time, allowing automobiles to be manufactured in hours rather than days. As a result, Ford Motor Company achieved remarkable growth and made automobiles affordable for a much larger population. The historical photograph illustrates a typical assembly line from that era. Notice how workers are positioned along a fixed production line, each responsible for a particular operation. This arrangement increased productivity because every worker became highly skilled at a single task, and products flowed continuously through the factory. Although this system revolutionized manufacturing, it also had important limitations. Workers were often treated as if they were simply one part of the machine, repeatedly performing the same task with little flexibility or involvement in improving the process. This highly rigid approach focused almost entirely on producing large quantities of identical products. While it worked well for stable markets, it became less effective when customer demands changed or when greater product variety was required. By the 1970s and 1980s, many industries began facing serious challenges. Customers wanted more choices, higher quality, and faster responses to changing market needs. Traditional mass production systems struggled to adapt because they were designed for uniformity rather than flexibility. This exposed the weaknesses of the earlier manufacturing philosophy. These challenges eventually motivated companies to search for better production methods that could combine efficiency with flexibility and quality. One of the most successful responses came from Toyota, whose manufacturing philosophy introduced continuous improvement, waste reduction, and greater employee involvement. These ideas later became the foundation of modern lean manufacturing. Understanding this historical evolution is important, because Lean did not emerge in isolation. It developed as a response to the limitations of traditional mass production, demonstrating that sustainable operational excellence. The success of Lean manufacturing is closely linked to the remarkable transformation of Toyota. During the 1950s, Japan faced a very different economic environment from the United States. While American companies like Ford focused on producing large volumes of identical vehicles, Japan had a smaller market, with customers demanding greater variety. This made traditional mass production less practical. A turning point came in 1950 when E.G. Toyota visited one of Ford's manufacturing plants. He carefully studied the assembly line and realized that simply copying Ford's production system would not meet Japan's unique market needs. Instead, he and his team developed the Toyota Production System, a new manufacturing approach designed to achieve efficiency without sacrificing flexibility. At the heart of this system was the philosophy known as Kaizen, a Japanese term meaning continuous improvement. Rather than making large changes only once in a while, Kaizen encourages employees at every level to identify small improvements every day. These incremental changes may seem minor individually, but over time, they lead to significant gains in productivity, quality, and customer satisfaction. The factory image represents this modern production environment, where technology, standardized workflows, and employee involvement work together to create an efficient manufacturing system. Unlike traditional factories, employees are encouraged not only to perform their tasks, but also to suggest better ways of completing them. The Toyota Production System achieved what many organizations believed was impossible. It combined low production costs with high product quality, while still allowing manufacturers to produce different models according to customer demand. This ability to balance efficiency, quality, and customization enabled Toyota to grow from a relatively small automobile manufacturer into one of the world's leading automotive companies. The principles developed by Toyota later became the foundation of lean methodology and continue to influence manufacturing, healthcare, banking, software development, and robotic process automation. They demonstrate that long-term success is achieved through continuous improvement rather than one-time optimization efforts. Before Lean became widely recognized, Another important management philosophy helped shape modern quality improvement practices. This philosophy was total quality management, commonly known as TQM. Its primary goal is to achieve continuous improvement by using data, statistics, and the active participation of everyone in the organization. One of the key contributors to TQM was W. Edwards Deming, a statistician whose ideas transformed manufacturing around the world. Although his methods initially received limited attention in the United States, they were enthusiastically adopted by Japanese industries. His work became one of the major foundations for Japan's manufacturing success, and later influenced both Lean and Six Sigma methodologies. The central principle of TQM is customer focus. Every process improvement should ultimately create greater value for the customer. Instead of improving processes simply to reduce costs, organizations ask whether the improvement enhances customer satisfaction and product quality. Another important principle is continuous improvement. Rather than assuming that a process is already perfect, organizations continuously look for opportunities to make it better. Even small improvements made consistently over time can produce significant long-term benefits. TQM also emphasizes employee involvement. Quality is not the responsibility of a single department. It is everyone's responsibility. Employees are encouraged to identify problems, suggest improvements, and actively participate in achieving organizational goals. This collaborative approach creates a culture where improvement becomes part of daily work. The final principle is fact-based decision-making. Instead of relying on assumptions or personal opinions, managers use data, measurements, and statistical analysis to understand process performance. Decisions supported by accurate information are more reliable and lead to better business outcomes. These four principles work together to create an organization that continuously learns and improves. Customer focus defines the goal, continuous improvement drives progress, employee involvement provides ideas and commitment, and fact-based decisions ensure that improvements are supported by evidence. These concepts later became essential building blocks for Lean, Six Sigma, and ultimately robotic process automation, where high-quality, well-defined processes are critical for successful automation. One of the most important concepts in Lean methodology is the principle of value. In Lean, value is defined very simply. It is anything that the customer is willing to pay for. This means that every activity performed within an organization should contribute directly or indirectly to meeting customer needs. If an activity does not add value, it becomes a candidate for improvement or elimination. Understanding customer value is not always straightforward. Customers may not explicitly describe everything they expect, and their preferences often change over time. Therefore, organizations must continuously study market trends, analyze customer feedback, and understand changing consumer behavior. Only by doing this can they accurately determine what customers truly consider valuable. The image highlights 3 stages where value must be created throughout the business process. The first stage is development. During product design and planning, organizations must understand customer expectations and ensure that the product is designed to satisfy those needs. Decisions made at this stage have a major influence on the overall quality and usefulness of the final product. The second stage is production. Once the design is complete, the focus shifts to manufacturing or service delivery. Lean aims to streamline operations by removing unnecessary steps, reducing waiting time, eliminating defects, and improving workflow efficiency. This ensures that value is created with minimum waste. The third stage is distribution. Even a high-quality product loses value if it reaches the customer late or at excessive cost. Therefore, Lean also optimizes transportation, inventory management, and logistics so that products are delivered quickly, reliably, and economically. Consider an online shopping company as an example. Customers value accurate products, fast delivery, and reasonable prices. If the company simplifies warehouse operations, reduces packing errors, and optimizes delivery routes, it creates greater customer value while lowering operational costs. The key lesson is that Lean encourages organizations to evaluate every activity from the customer's perspective. By focusing only on work that creates value and eliminating everything else, businesses become more efficient, competitive, and better prepared for successful automation through RPA. An important step in Lean methodology is mapping the value stream. A value stream represents the complete sequence of activities required to deliver a product or service to the customer, beginning with the initial idea and ending with the final delivery. By mapping every step, organizations can clearly identify which activities create value and which simply consume time, money, or resources. The value stream is typically viewed in 3 major stages. The first stage is development. This is where customer requirements are understood, products are designed, and planning activities take place. Decisions made during this stage have a significant impact on cost, quality, and customer satisfaction. A well-planned design reduces the chances of problems occurring later in the process. The second stage is production. Here, the focus is on transforming raw materials or information into the final product or service. Lean encourages organizations to streamline operations by removing unnecessary activities, reducing waiting time, preventing defects, and improving workflow. Every improvement made during production helps reduce waste while increasing efficiency. The final stage is distribution. Even if a product is designed and manufactured perfectly, it provides little value if it does not reach the customer efficiently. Therefore, organizations optimize transportation, inventory management, and logistics to ensure timely delivery while keeping costs under control. Consider an online shopping company. During development, the company designs a user-friendly website and understands customer expectations. During production, orders are processed accurately and packed efficiently. During distribution, delivery routes are optimized so customers receive their purchases quickly. Mapping the entire value stream allows the company to identify delays or unnecessary activities at every stage and continuously improve the overall process. The main objective of value stream mapping is to visualize the complete workflow from start to finish. By distinguishing value-adding activities from non-value-adding ones, organizations can eliminate waste, improve customer satisfaction, and create streamlined processes that are ideal for successful robotic process automation. An efficient process is not created by chance. It depends on two closely connected principles in lean methodology known as flow and pull. Together, these principles help organizations deliver products and services quickly while avoiding unnecessary waste. Flow refers to the smooth movement of work through every stage of a process. Instead of allowing work to stop, wait, or accumulate between activities, the entire process is divided into smaller, well-organized steps. Each step is carefully optimized so that work moves continuously from one stage to the next. When flow is properly maintained, organizations reduce waiting time, eliminate bottlenecks, and improve overall productivity. Imagine a hospital where patients must visit registration, consultation, laboratory testing, and the pharmacy. If each department works efficiently, and patients move smoothly from one service to another, without unnecessary waiting, the hospital has achieved good process flow. The same concept applies to business processes and RPA workflows. The second principle is pull, which is closely associated with the just-in-time approach. Instead of producing goods or performing work based on predictions, organizations produce only what is needed, when it is needed, and in the required quantity. This prevents excess inventory, reduces storage costs, and minimizes waste. Consider a restaurant as an example. Meals are usually prepared only after a customer places an order, rather than cooking large quantities in advance. This ensures freshness, reduces food waste, and avoids unnecessary inventory. Similarly, in manufacturing, companies produce products according to actual customer demand, rather than building large stocks that may never be sold. For the pull system to work effectively, organizations must clearly understand customer demand and accurately identify what customers value. Without this knowledge, they risk producing either too much or too little. Together, flow and pull create a highly efficient process. Flow ensures that work progresses smoothly without interruptions, while pull ensures that resources are used only when there is genuine demand. These principles not only reduce operational costs, but also improve customer satisfaction, making business processes well-suited for successful robotic process automation. One of the core principles of Lean is the pursuit of perfection through continuous improvement. Unlike traditional approaches that aim for a one-time solution, Lean considers improvement as an ongoing journey. The goal is not to become perfect overnight, but to continuously identify better ways of performing work, eliminating waste, and delivering greater value to customers. This philosophy is known as Kaizen, a Japanese word meaning continuous improvement. Kaizen encourages every employee, regardless of their role, to look for small, practical improvements in their daily work. While each improvement may appear minor, the combined effect of many small changes over time can produce significant gains in productivity, quality, and efficiency. An important aspect of Kaizen is that improvement is everyone's responsibility, not just that of managers or quality specialists. Employees who perform a task every day often have the best understanding of the challenges they face. By empowering them to suggest ideas and solve problems independently, organizations create a culture where innovation becomes part of everyday work. Consider a customer support center as an example. Instead of waiting for a major system upgrade, employees may identify simple improvements such as reorganizing frequently used information, reducing unnecessary approval steps, or creating standard response templates. Each change saves only a small amount of time, but when repeated thousands of times, the overall improvement becomes substantial. This principle also applies to robotic process automation. Before automating a process, organizations should continuously refine and simplify it. Automating an inefficient process only allows errors to occur faster. However, when a process has been improved through Kaizen, automation delivers greater speed, accuracy, and reliability. The key message is that Lean views perfection as a continuous journey rather than a final destination. Organizations that encourage continuous improvement create adaptable, efficient processes that remain competitive and are well prepared for successful automation. Successfully implementing Lean requires more than introducing new tools or improving individual processes. It demands a fundamental change in an organization's mindset and culture. Lean is not a short-term initiative designed to solve a single problem. Instead, it is a long-term commitment to continuously improving the way work is performed. The image illustrates a team collaboratively mapping a business process. This represents one of the key practices in Lean implementation. Employees from different departments work together to understand existing workflows, identify inefficiencies, and design better ways of completing tasks. Since every team member contributes unique knowledge and experience, collaboration often leads to more practical and sustainable improvements. A successful Lean journey should begin with a manageable problem, rather than attempting to transform the entire organization at once. Solving a small but meaningful problem allows employees to understand Lean principles, gain confidence, and develop the skills needed for larger improvement projects. These early successes also encourage wider acceptance of Lean practices throughout the organization. Communication is another critical factor in Lean implementation. Continuous improvement requires employees to share ideas, report issues, and monitor progress effectively. Many organizations use digital collaboration platforms, such as Slack, Microsoft Teams, or Asana, to coordinate improvement activities, assign responsibilities, and track completed tasks. These tools improve transparency and help teams stay aligned without requiring complex project management systems. Consider a company preparing to automate its invoice processing using RPA. Instead of immediately automating the existing workflow, the team first maps the entire process, identifies unnecessary approval steps, removes duplicate data entry, and standardizes the workflow. Once the process becomes simpler and more efficient, automation can deliver much greater benefits with fewer errors. The key message is that Lean succeeds when it becomes part of the organization's culture. By encouraging teamwork, continuous learning, open communication, and gradual improvement, businesses build efficient, standardized processes that provide a strong foundation for successful robotic process automation. We now move from Lean, which focuses on eliminating waste, to Six Sigma, a methodology that concentrates on improving quality and consistency. While Lean asks how a process can be made faster and more efficient, Six Sigma asks how it can be made more accurate by reducing defects and unwanted variation. Six Sigma was formalized by Motorola during the mid-1980s and later became widely known when General Electric, under the leadership of Jack Welch, adopted it across the organization. Its success demonstrated that data-driven decision-making could significantly improve business performance and product quality. The primary objective of Six Sigma is to identify defects, understand their root causes, and eliminate them through systematic analysis. A defect is any outcome that fails to meet customer expectations or quality standards, while variation refers to differences in process performance that lead to inconsistent results. By reducing both defects and variation, organizations create processes that are more predictable, reliable, and efficient. Unlike approaches that rely on assumptions or intuition, Six Sigma is based on measurable data. Teams collect information about process performance, analyze trends, identify the actual causes of problems, and implement solutions supported by evidence. This disciplined approach ensures that improvements are sustainable rather than temporary. Consider a banking example. If loan approvals take different amounts of time for similar applications, the process has unnecessary variation. If customer information is entered incorrectly, those errors become defects. Six Sigma techniques help analyze these issues, identify their causes, and standardize the workflow so approvals become both faster and more accurate. Although Lean and Six Sigma have different areas of focus, they complement each other effectively. Lean removes unnecessary activities that waste time and resources, while Six Sigma improves the quality and consistency of the remaining process. Together, they provide a strong foundation for robotic process automation, because software robots perform best when business processes are both efficient and free from unnecessary errors. The term Six Sigma originates from statistics, where sigma represents the standard deviation, a measure of how much data varies from its average value. In any business process, some variation is natural, but excessive variation often leads to defects, inconsistencies, and reduced customer satisfaction. Six Sigma aims to minimize this variation so that processes produce highly consistent and reliable results. The figure on this slide illustrates the normal distribution, commonly known as the bell-shaped curve. In a stable process, most outcomes are clustered around the average, while fewer observations appear as we move further away from the center. The closer process results remain to the average, the more predictable and consistent the process becomes. The slide also highlights an important statistical concept. Approximately 68.26% of all observations in a normal distribution lie within one standard deviation, or 1 sigma from the mean. As additional standard deviations are included, a larger percentage of observations falls within the acceptable range. Six Sigma extends this concept to 6 standard deviations, representing an extremely high level of process consistency with very few defects. Although the statistical calculations behind Six Sigma can be complex, the business objective is straightforward. By measuring process performance using data instead of assumptions, organizations can identify where variations occur, understand why they happen, and implement improvements that make the process more stable and predictable. Consider a manufacturing company producing electronic components. If the dimensions of each component vary significantly, some products may not fit correctly and will be rejected as defective. By applying Six Sigma techniques, engineers measure these variations, identify their root causes, and adjust the manufacturing process so that nearly every component meets the required specifications. The same principle applies to service industries. For example, a bank can analyze variations in loan processing times or transaction errors, and use Six Sigma methods to make its services more consistent and reliable. The key takeaway is that Six Sigma transforms quality improvement into a measurable, data-driven process. Instead of relying on guesswork, organizations use statistical analysis to control variation, reduce defects, and consistently deliver high-quality products and services. One of the defining goals of Six Sigma is achieving an extremely low defect rate. This target is measured using a metric called defects per million opportunities, or DPMO. An opportunity represents any point in a process where a defect could occur. Instead of simply counting the total number of defects, Six Sigma measures how many defects occur for every 1 million opportunities, allowing organizations to compare quality across different processes. The benchmark for a Six Sigma process is 3.4 defects per million opportunities. Although this number may seem incredibly small, it represents a process that is highly stable, predictable, and capable of producing consistent results with almost no errors. This level of quality is often referred to as near-perfect performance. Reaching Six Sigma quality is challenging, because many business processes naturally experience variation. In reality, most organizations operate between the 3 Sigma and 4 Sigma levels, where defect rates are considerably higher. Six Sigma provides a structured methodology to analyze these processes, identify the causes of defects, and continuously improve performance until the defect rate is significantly reduced. Consider a credit card company processing 1 million transactions. If it operates at the Six Sigma level, only about 3 or 4 transactions would contain errors. However, if the process operates at a lower Sigma level, thousands of transactions might contain mistakes, leading to customer complaints, financial losses, and additional correction work. The same concept applies to manufacturing. Imagine a factory producing 1 million electronic chips. A Six Sigma process would produce only a handful of defective chips, while a lower quality process could generate thousands of faulty products, increasing production costs and reducing customer trust. The important point is not that every organization must immediately achieve 3.4 DPMO, but that Six Sigma provides a measurable quality target. By continuously monitoring defects and analyzing process performance, organizations can systematically improve reliability, reduce waste, and deliver better products and services. These highly consistent and standardized processes also become excellent candidates for robotic process automation, because software robots perform most effectively when process variations and defects have already been minimized. Compare the quality of different processes fairly. Six Sigma uses a metric called defects per opportunity, or DPO. Simply counting the total number of defects is often misleading, because different processes have different levels of complexity. A process with more steps naturally has more chances for defects to occur than a simpler process. DPO solves this problem by measuring defects relative to the total number of opportunities for errors. A defect is any outcome that does not meet the required quality standard, while an opportunity is any point in the process where such a defect could occur. DPO is calculated by dividing the total number of defects observed by the total number of defect opportunities. This creates a standardized measure that allows organizations to compare processes of different sizes and complexities. Imagine comparing 2 manufacturing lines. One process consists of only 10 steps, while another has 100 steps. If both produce 20 defects, it would seem that their quality is the same. However, the second process has many more opportunities for defects, so its actual performance is much better. DPO reveals this difference, making comparisons more meaningful and accurate. The same concept applies to service industries. Consider 2 banking processes. Opening a savings account may involve only a few verification steps, whereas approving a home loan requires extensive documentation and multiple approval stages. Even if both processes record the same number of errors, the home loan process may actually have a lower DPO, because it has far more opportunities for mistakes. This allows managers to evaluate quality fairly, instead of relying only on raw defect counts. By using DPO, organizations establish a common quality measurement across all business processes. Managers can identify which processes require improvement, monitor progress over time, and compare performance across different departments or products using the same standard. This standardized measurement plays a crucial role in Six Sigma, because effective improvement begins with accurate measurement. Once organizations understand where defects occur and how frequently they occur relative to available opportunities, they can focus their improvement efforts where they will have the greatest impact. creating reliable processes that are well suited for robotic process automation. This example demonstrates why defects per opportunity, DPO, provides a more meaningful measure of quality than simply counting the total number of defects. At first glance, two manufacturing processes may appear to perform equally because they produce the same number of defects. However, once process complexity is considered, the actual quality can be very different. The first example is a simple mirror assembly process consisting of only 20 steps. Although it records 5,000 defects, those defects occur across a relatively small number of opportunities. As a result, its DPO is 0.05, which corresponds to 50,000 defects per million opportunities, DPMO. This indicates that the process has a relatively high defect rate. The second example is a complex engine assembly process involving 1,000 steps. It also records 5,000 defects, but because there are far more opportunities for defects to occur, its DPO is only 0.001, equivalent to 1,000 DPMO. Even though both processes have the same number of defects, the engine assembly process actually performs much better in terms of quality. This example shows why raw defect counts can be misleading. If managers looked only at the number of defects, they would conclude that both processes have identical performance. DPO provides a fair comparison by considering the complexity of each process and the total number of opportunities where defects could occur. A similar situation exists in service industries. Consider a bank where opening a savings account requires only 5 steps, while processing a home loan involves hundreds of verification and approval activities. If both processes produce 10 errors, it would be incorrect to assume they have the same quality. Since the loan process has many more opportunities for mistakes, its DPO may actually be much lower, indicating better overall performance. This is why Six Sigma relies on standardized metrics such as DPO and DPMO instead of simple defect counts. They provide a realistic measure of process quality, help organizations compare different operations fairly, and identify where improvement efforts should be focused. Such accurate measurement is essential for building stable, reliable processes that are ideal for successful robotic process. One of the most interesting aspects of Six Sigma is that improvements are exponential rather than linear. This means that even a small increase in the Sigma level can produce a dramatic reduction in defects and a significant improvement in overall process quality. The slide compares a process operating at 3 Sigma with one operating at 4 Sigma. At the 3 Sigma level, the process produces approximately 66,807 defects per million opportunities, which means about 93.3% of the outputs meet the required quality standard. Although this may seem acceptable, thousands of defects can still occur when large volumes are produced. When the same process is improved to 4 Sigma, the number of defects falls sharply to about 6,210 defects per million opportunities, while the process yield increases to approximately 99.38%. This single-level improvement reduces defects by nearly 10 times, demonstrating why Six Sigma organizations focus on gradually increasing Sigma levels. Consider a manufacturing plant producing 1 million electronic devices. At the 3 Sigma level, over 66,000 products could contain defects requiring repair or replacement. After improving the process to 4 Sigma, the number of defective products drops to just over 6,000. This not only reduces production costs, but also improves customer satisfaction and strengthens the company's reputation. The same principle applies to service industries. For example, if a bank processes 1 million online transactions, moving from 3 Sigma to 4 Sigma significantly reduces transaction errors, resulting in faster service, fewer customer complaints, and lower operational costs. The key lesson is that every improvement in the Sigma level delivers disproportionately larger quality benefits. Small process improvements can therefore produce major business results. This is why organizations continuously measure, analyze, and refine their processes, instead of settling for average performance. By steadily increasing process capability and reducing defects, Six Sigma creates highly reliable workflows that are ideal for robotic process automation, where consistent and error-free processes lead to the best automation outcomes. Six Sigma follows a structured improvement methodology known as DMAIC. The name is formed from the first letters of its 5 phases: define, measure, analyze, improve, and control. This framework provides a systematic approach for solving process problems using data rather than assumptions. The first phase is define. In this stage, the organization clearly identifies the problem, understands customer requirements, and establishes the project goals. A well-defined problem ensures that the improvement effort focuses on the right objective. The second phase is measure. Here, teams collect data to understand how the current process is performing. Instead of relying on opinions, they measure important indicators, such as processing time, defect rates, or customer complaints. This creates a reliable baseline for comparison. The third phase is analyze. The collected data is carefully examined to identify the root causes of defects, delays, or process variations. Rather than treating symptoms, Six Sigma focuses on discovering the actual reasons behind poor performance, so that lasting improvements can be achieved. The fourth phase is improve. Based on the analysis, the team develops and implements solutions to eliminate the identified root causes. The effectiveness of these improvements is then verified using data to ensure that the desired results have been achieved. The final phase is control. Once improvements have been successfully implemented, organizations establish monitoring systems, standard operating procedures, and performance measures to ensure that the process continues to perform at the improved level. Without proper control, processes may gradually return to their previous inefficient state. Consider a customer support center receiving a large number of delayed complaint resolutions. The team first defines the problem, measures response times, analyzes the reasons for delays, introduces improved workflows and automation, and finally monitors performance to ensure the improvements are sustained over time. The DMAIC framework provides a disciplined and repeatable approach to continuous improvement. By following these 5 phases, organizations create stable, efficient, and high-quality processes that form an excellent foundation for successful robotic process automation. The first 3 phases of the DMAIC methodology focus on understanding a problem before attempting to solve it. This structured approach ensures that decisions are based on facts and evidence rather than assumptions. The first phase is define. During this stage, the team clearly identifies the business problem and understands how it affects customers or organizational performance. The scope of the project, customer requirements, and expected outcomes are established so that everyone works toward the same objective. A clearly defined problem is the foundation of every successful improvement project. The second phase is measure. Once the problem is defined, the next step is to collect accurate data about the current process. Teams measure key performance indicators such as processing time, error rates, customer complaints, or operational costs. This creates a baseline that shows how the process is performing before any improvements are made. Without reliable measurements, it is impossible to determine whether future changes actually improve the process. The third phase is analyze. In this stage, the collected data is carefully examined to identify the root causes of defects, delays, or process variations. Instead of addressing only the visible symptoms, Six Sigma seeks to discover the actual reasons behind poor performance. Various analytical techniques are used to determine why problems occur and which factors have the greatest impact on process quality. Consider a company experiencing delays in customer order processing. During the define phase, the team identifies delayed deliveries as the business problem. In the measure phase, they collect data on processing times at each stage of the workflow. During the analyze phase, they discover that most delays occur because orders require repeated manual verification. This understanding allows the organization to develop targeted solutions rather than making unnecessary changes elsewhere. These first 3 phases transform a practical business issue into a clearly understood, data-driven problem. By thoroughly defining, measuring, and analyzing the process, organizations establish a strong foundation for implementing effective improvements and achieving long-term operational excellence. The final 2 phases of the DMAIC methodology focus on implementing effective solutions and ensuring that the improvements are maintained over time. These stages transform analysis into measurable business results. The fourth phase is improve. After identifying the root causes of defects or delays, the team develops practical, data-driven solutions. These solutions are implemented carefully and tested to verify that they actually improve process performance. Rather than making changes based on assumptions, every improvement is validated using measurable results, such as reduced processing time, fewer defects, or increased customer satisfaction. The fifth phase is control. Achieving improvement is only the beginning. Maintaining it is equally important. In this phase, organizations establish control plans, standard operating procedures, performance dashboards, and regular monitoring systems to ensure that the improved process continues to perform consistently. If performance begins to decline, corrective actions can be taken immediately before major problems develop. Consider a company that improves its invoice processing system. During the improve phase, it removes unnecessary approval steps and introduces automated validation using RPA. These changes reduce processing time and minimize manual errors. During the control phase, managers continuously monitor processing times, error rates, and system performance using reports and predefined quality standards. This ensures that the benefits achieved through the project are sustained over the long term. The improve and control phases work together to convert analytical findings into lasting operational success. Improve focuses on implementing the right solution, while control ensures that the organization does not return to its previous inefficient practices. This structured approach makes Six Sigma highly effective for continuous improvement and provides an ideal foundation for robotic process automation, where standardized, stable, and well-controlled processes enable software robots to operate efficiently and consistently. Successful Six Sigma implementation requires clearly defined leadership roles. Since process improvement often affects multiple departments, Organizations assign specific responsibilities to ensure projects are properly planned, supported, and completed. The slide highlights 3 key leadership roles: executive, champion, and process owner. The executive provides strategic direction and overall support for Six Sigma initiatives. Executives approve projects, allocate budgets, establish organizational objectives, and ensure that improvement efforts align with business goals. Their commitment is essential because major process improvements often require organizational resources and long-term investment. The second role is the champion. Champions are responsible for managing Six Sigma projects at the operational level. They coordinate activities across departments, provide the necessary resources, remove obstacles that may delay progress, and ensure that project teams remain focused on achieving their objectives. They act as a bridge between senior management and the improvement teams. The third role is the process owner. This individual is directly responsible for the day-to-day performance of a specific business process. The process owner works closely with the project team, monitors process performance, implements recommended improvements, and ensures that the changes are sustained after the project is completed. They also use data and statistical techniques to evaluate whether the process continues to meet quality standards. Consider a bank aiming to reduce the time required for loan approval. The executive approves the project and provides organizational support. The champion coordinates teams from customer service, risk assessment, and IT while resolving operational challenges. The process owner manages the loan approval workflow, implements the improvements, and continuously monitors performance to ensure that processing time remains low and service quality remains high. These leadership roles work together to ensure that Six Sigma projects are not only completed successfully, but also deliver long-term business value. Clear responsibilities, effective coordination, and continuous monitoring create stable, high-quality processes that provide an excellent foundation for successful robotic process automation. Six Sigma uses a belt-based certification system, inspired by martial arts, to represent different levels of knowledge, responsibility, and expertise in process improvement. As individuals gain experience and advanced skills, they progress through higher belt levels and take on more complex improvement projects. The first level includes white belt and yellow belt professionals. They understand the basic concepts of Six Sigma and contribute by identifying problems, supporting improvement activities, and reporting quality issues. Although they do not usually lead projects, they play an important role by participating in improvement initiatives within their teams. The next level is the green belt. Green belts have a deeper understanding of Six Sigma tools and techniques. They actively participate in project teams and are capable of leading smaller improvement projects within their departments. While continuing their regular job responsibilities, they use data analysis and problem-solving methods to improve process performance. Above this is the black belt level. Black belts possess advanced expertise in Six Sigma methodologies and statistical analysis. They work full-time on improvement projects, lead cross-functional teams, solve complex business problems, and mentor green belts. Their primary responsibility is to deliver measurable improvements in quality, efficiency, and customer satisfaction. The highest certification is the Master Black Belt. These professionals are experienced experts who guide the organization's overall Six Sigma strategy. They train and coach black belts and green belts, establish best practices, and help create a culture of continuous improvement throughout the organization. They also advise senior management on selecting and managing strategic improvement projects. Consider a manufacturing company implementing Six Sigma. Yellow belts identify production issues. Green belts lead departmental improvement projects. Black belts manage large quality initiatives across multiple departments, and master black belts develop the organization's long-term quality strategy while mentoring other team members. Lean and Six Sigma are powerful methodologies on their own, but many organizations achieve even greater results by combining them into a single approach called Lean Six Sigma. This integrated methodology brings together the strengths of both systems to improve efficiency and quality at the same time. Lean focuses on eliminating waste by simplifying workflows and removing activities that do not add value to the customer. It helps organizations reduce delays, eliminate unnecessary steps, and improve the overall speed of business processes. The goal is to ensure that every activity contributes to creating customer value. Six Sigma, in contrast, concentrates on preventing defects and reducing process variation. It uses data, measurement, and statistical analysis to identify the root causes of errors and improve process consistency. This ensures that products and services meet customer expectations with minimal defects. Lean Six Sigma combines these complementary strengths. Lean makes processes faster and more efficient, while Six Sigma makes them more accurate and reliable. Together, they create streamlined processes that are both cost-effective and capable of delivering consistently high-quality results. Consider a hospital as an example. Lean principles can reduce patient waiting times by removing unnecessary administrative steps and improving patient flow. At the same time, Six Sigma techniques can reduce medication errors and improve the accuracy of patient records. By applying both methodologies together, the hospital provides faster service while maintaining high standards of patient safety and quality. The same concept applies to robotic process automation. Before automating a business process, organizations should first eliminate waste using Lean, and then reduce defects using Six Sigma. Once the process becomes both efficient and reliable, software robots can automate it with greater accuracy, fewer exceptions, and improved performance. The key idea is that Lean Six Sigma is not simply the addition of two methodologies. It is an integrated approach that balances efficiency with quality, enabling organizations to maximize customer value, improve operational performance, and build robust processes that are ideal for successful automation. An important tool within Lean Six Sigma is the 5S framework, which creates a clean, organized, and efficient workplace. Although it was originally developed for manufacturing, the 5S principles are now widely applied in offices, hospitals, IT organizations, and robotic process automation projects. A well-organized work environment reduces waste, improves productivity, and minimizes errors. The first step is sort. This involves identifying and removing unnecessary items, documents, tools, or activities that are not required for the current work. Eliminating clutter makes it easier to focus on essential tasks and prevents wasted time searching for resources. The second step is straighten, sometimes called set in order. After unnecessary items have been removed, the remaining resources are arranged logically, so they are easy to locate and use. Every tool, document, or digital file should have a designated place, allowing employees to work efficiently without unnecessary delays. The third step is shine. This means keeping the workplace clean, well-maintained, and free from conditions that could lead to mistakes or equipment failures. A clean environment helps identify problems early and creates a safer, more productive workplace. The fourth step is standardize. Once effective practices have been established, organizations create standard procedures so that everyone follows the same methods. Standardization ensures consistency, improves quality, and makes training new employees much easier. The final step is sustain. Maintaining improvements requires discipline and continuous commitment. Regular reviews, audits, and employee involvement help ensure that the first four steps become permanent habits rather than temporary improvements. Consider an RPA development team. Unnecessary project files are removed during sort. Automation scripts and documentation are organized during straighten. The development environment is kept clean during shine. Coding standards are established during standardize, and regular reviews ensure these practices continue through sustain. The 5S framework demonstrates that operational excellence begins with organization and discipline. By creating a structured and standardized workplace, organizations improve efficiency, reduce errors, and build strong processes that support successful robotic process automation. Before implementing robotic process automation, organizations should ensure that their business processes are efficient, standardized, and free from unnecessary problems. This slide emphasizes that applying Lean and Six Sigma before automation significantly increases the value and success of RPA initiatives. The illustration of a structured digital workspace represents the idea of analyzing how employees perform their daily tasks before introducing software robots. Instead of immediately automating an existing process, organizations should first understand every activity, identify delays, and remove unnecessary steps. This ensures that automation improves the process rather than simply making an inefficient workflow run faster. An important activity before automation is identifying bottlenecks. A bottleneck is any stage in a process that slows down the overall workflow. For example, if every customer request waits several hours for manual approval, that approval stage becomes the bottleneck. Removing or simplifying such delays improves efficiency, even before automation begins. The slide also introduces failure mode and effect analysis, commonly called FMEA. FMEA is a systematic technique used to identify potential failures in a process, understand their possible causes, evaluate their impact, and prioritize corrective actions. By predicting problems in advance, organizations can prevent errors instead of reacting after they occur. Another valuable practice is observing how employees actually perform their work. This is sometimes called desk mapping or process walkthrough. By watching each step, organizations often discover repeated data entry, unnecessary approvals, manual calculations, or duplicated tasks that can either be eliminated or automated more effectively. Consider an accounts payable department processing invoices. If the organization first removes duplicate approvals, standardizes invoice formats, and identifies possible failure points using FMEA, the RPA solution becomes much simpler, faster, and more reliable. The software robot spends its time performing value-adding work instead of repeating inefficient manual practices. The key lesson is that successful RPA begins with process improvement. Lean removes waste, Six Sigma reduces defects, and techniques such as bottleneck analysis and FMEA ensure that only optimized, well-designed processes are automated.